Hey, welcome to The Explainer. Today we're peeling back the curtain on this amazing, invisible tech that makes your favorite streaming service, your social media feed, even your online shopping feel totally instant. It is the real engine of the modern internet, and we're about to see exactly how it all works. You know that feeling, right? You click a link, and one site just snaps onto your screen, but the next one gives you that dreaded spinning wheel of doom. Ever wonder why that happens? It's a super common frustration. And the answer, believe it or not, is surprisingly physical. Yep, that's right. Distance. See, when you go to a website, you're not just plucking it out of thin air. You're actually sending a request to a physical computer, a server, somewhere in the world. And that server has to send all that website data all the way back to you. So the farther away that server is, the longer it's going to take. And that delay, well, it has a name: latency. You can think of it like a kind of digital jet lag. It's the total round-trip time for your request to travel to the server and for the server's response to travel all the way back. So if we want to make the web faster, well, we have to figure out a way to solve this whole distance problem. So how in the world do we solve for distance? Okay, let's try an analogy. I want you to imagine that all the content on the entire internet lived in one gigantic digital super library. Now, in the early days of the web, this is pretty much how things worked. If you wanted a specific thing, a website, an image, a video, you had to send your request all the way to this one central library, no matter where you were. You could be across the street or across the planet. Pretty inefficient, right? The solution, then, is actually brilliantly simple. Instead of everybody having to go to that one main library, what if the library built a whole network of local branches? And what if it stocked those branches with copies of all the most popular stuff? Then you could just pop down to your neighborhood branch and get what you need almost instantly. And that, right there, in a nutshell, is a content delivery network, or CDN for short. It's a network of servers that are strategically placed all around the globe. Those servers are our local library branches, and their entire job is to get you the content you want way faster by closing the physical distance. So let's just break this down side by side. On the left, you've got the old way. One single central origin server, that's our main library, trying to handle every single request from everyone, everywhere. That means high latency and a huge risk of getting overloaded. But on the right, you have the CDN way, a whole network of edge servers, our local branches, delivering content from right nearby. The result? Super low latency and way, way better performance. So what does this actually look like when you click on something? Let's follow your request on its lightning-fast journey when a CDN is involved. It's really this beautiful, high-speed dance of technology. It's kind of like a high-speed relay race. The moment you make a request, it's intercepted. Then, a system that works like a smart traffic cop, called a load balancer, instantly figures out the absolute best server for you based on your location. And that server, your local branch, it already has a copy of the website stored, or cached, so it just delivers it to you in like the blink of an eye. And that's the whole magic trick right there. The source material says it perfectly. The edge server's power comes from being at the closest physical location to the user. It really is that simple. Proximity is performance. Bringing the data closer to you just slashes that travel time we call latency. Okay, but that brings up a really good question. You're probably thinking, what happens if I ask for something that my nearest local branch doesn't have a copy of yet? Does the whole system just grind to a halt? No way. It's even smarter than that. So if the edge server doesn't have what you're looking for, it does a quick one-time trip back to the main origin server, our central library, to grab it. Then it delivers that content to you. But, and this is the really clever part, it also saves a copy for itself. It caches it. So the next time someone in your area asks for that same thing, boom, it's ready and waiting. This also means the main origin server isn't getting hammered with requests all the time, which keeps it healthy and stable. Now, speed is obviously the main event. But it turns out CDNs have some other superpowers that are just as important for keeping the internet running smoothly and safely. So the first hidden superpower is just plain old reliability. CDNs make websites so much more resilient and way less likely to just go down. I mean, think about it. If the whole web relied on single, central servers, one little hardware failure or one cut power cable could take a massive website completely offline. But with a CDN, the content is spread out across dozens, sometimes hundreds of servers all over the world. If one local branch has a problem, your traffic just gets automatically rerouted to the next closest healthy one. The result? You get near constant access. The content is just always on. And the second superpower, well, this one's a biggie: security. CDNs act as this incredibly powerful frontline defense against some of the most common cyber attacks out there. One of the biggest threats online is what's called a DDoS attack. That stands for Distributed Denial of Service. And it's basically a digital mob. Attackers use thousands of hacked computers to flood a website server with so much junk traffic that legitimate users, like you and me, can't get through. So how does a CDN stop this? Well, because it's this huge, distributed network, it can act like a giant sponge. It just absorbs the massive wave of junk traffic, spreading the attack out across all of its many servers. The attack gets completely diluted, and it never even gets a chance to overwhelm the main origin server, which stays safe, sound, and available for real users. So as we start to wrap up here, it's pretty clear that CDNs are the true unsung heroes of the internet. They're just working silently, tirelessly in the background, performing this incredible logistical feat every single second of every single day. So let's just do a quick recap of the key players using our library analogy. The origin server, that's the main library, the one single source of truth. The edge server, that's your local branch, right there in your neighborhood. And the cache, that's the collection of popular books it keeps on hand for fast access. And those local branches, the edge servers, they're all housed in physical data centers we call POPs, or points of presence. When you really stop and think about it, from streaming a 4K movie to having a live video chat with someone across the globe, none of it would be as fast, as reliable, or as secure without the silent, constant work of content delivery networks. They really are the invisible architecture of our digital lives. And that kind of leaves us with a final thought. We've just uncovered the invisible network that powers our present. So the question is, as our demands for data grow even more insane, what kind of new innovations are going to be needed to power our future? Thanks for joining us on The Explainer.